We're starting chapter 9, which is going to be discussing different ways that we can manipulate geometric figures. So you'll see that there's 5 different objectives for this section. We need to identify what an isometry is, so that's a vocab word, and then also looking at images and corresponding parts. Again, with images, that's like after we've manipulated our object, we call it an image. So we're going to have to look at those and see whether they're translations, how do we describe those translations, and what happens if we compose a translation or do more than one thing to that geometric figure. So the first thing we're going to do here is talk about some vocabulary. So I'm going to go ahead and write out these definitions for you. Our first word is transformation, and a transformation is when a geometric figure changes position, size, or shape. So if it changes position, size, or shape. Now we have some examples here with this domino. We have a domino flipping, we have a domino just sliding directions, and we have a domino turning. So this first one represents a reflection. We've flipped the domino. We also have a slide happening, which we call a translation, and we also have it turning, which we call rotating. So we're going to look at those throughout this chapter. Transformation is the general term for any of those things happening. We also have the word preimage, which means the original figure. And then the image is the resulting figure. So basically preimage before, image after. Before, after. Isometry is a transformation in which the preimage and the image are congruent. So an isometry is a transformation in which the preimage and the image are congruent. A translation maps all points of a figure the same direction and distance. And then our last definition is composition of transformations, which means performing multiple transformations on the same preimage. So just doing multiple things to it. Okay, so here we have identifying an isometry. So we have 3 examples, and I want you to look at them and see, are they an isometry? Now remember, your definition of an isometry is same shape, same size. Technically, the definition we have on the last page there is that they are congruent. The preimage and the image are congruent. So in your brain, you should be thinking same shape, same size. These 2 things must be congruent. So you need to look at these pictures and see if they are in fact congruent or not. Okay, so here we need to talk about how we notate a transformation. Now you see that on this page you have a lot of these little apostrophes. Those are called primes. You see that here. Prime notation is this little apostrophe, and it's used to show that that's where the point is going to. So if you look at this picture here, J went to J prime. That's your new point. K went to K prime. And Q went to Q prime. So when you talk about that triangle, triangle JKQ went to triangle J prime, K prime, Q prime. It was mapped to that. So that little arrow there means it was mapped onto this new triangle. So if we look at the example, in the diagram we have E prime, F prime, G prime, H prime, this picture here, and it says that that's the image of E, F, G, H. So we started here with this black image, we went to the blue image here. So what you need to do is determine what are the images of F and H. It's actually quite simple because they're named so that it's corresponding. The image of F is F prime, and the image of H is H prime. And you could say the same thing for all of the different angles in this picture. Now, we also have corresponding sides. So, for example, EF corresponds with E prime, F prime. Same thing you could say with, say, EH. EH corresponds with E prime, H prime. And you can continue for the other two sides as well. So now for this problem, I want you to determine what are the images of I and D, and then also what are the pairs of corresponding sides. Now, I want to point out one thing to you guys. You may be given a picture. Sometimes the picture is a little bit hard to see. Did they reflect it? Did they rotate it? What's happening? So you can always, always, always depend on the information they give you. So if they say triangle NID is mapped to triangle SUP, it's in a specific order. So N mapped to S, and etc. from there. So you can take a look at either this image or you can just look at this statement right here to answer those two questions. Okay, so now we're going to talk about finding the image, and then we're going to get into rules of how we are mapping. So if you look at this first picture right here, I have these two squares, and it says that ABCD was mapped onto A prime, B prime, C prime, D prime by moving point B 4 units to the right and 2 units down. Did the same thing with A. A went 4 units to the right, 2 units down. Same thing with C and D. They all follow the same rule. Okay, so let's look at our first example. What are the images of vertices P, Q, and R for the translation? Oh, here's your rule. Your X and your Y values are being shifted. My X is losing 2, and my Y is losing 5, which really, if your X is being made smaller or you're taking away from it, that means you're going left 2. And if your Y is being subtracted from, that means you're going down 5. So my rule is left 2, down 5. So I'm going to take this picture here, and I'm going to do that. I'm going to go left 2 from R, and then I'm going to go down 5. And I'm going to put a point there. Right there. And I'm going to call it R prime. I'm also going to do the same thing with Q. Left 2, down 5. I'm going to call that Q prime. And same with P. Left 2, down 5. And I get P prime. So now there is my new picture, and it's not perfect, but you can tell that I've taken that image and I've moved it. This was my pre-image, this is my image, and it's asking me to graph it using that rule, so I'm done. I took my red triangle, I followed the rule down left 2, down 5, I created my image, and now I'm done. So there's a U-try problem for you at the bottom of this slide. Go ahead and do that and bring it to class tomorrow. And now on this slide, we're kind of going the opposite direction. So if you look at this example here, they gave you P, Q, R, S, and its image, P prime, Q prime, R prime, S prime. So they've given you both of these pictures. They want you to find the rule. So I have to figure out, how did I get from P to P prime? Well, let's just look at our picture. From P to P prime, I went right by 1, 2, 3, 4, 5, 6, 7, 8. So let's write that down. I went right by 8. Okay, now if I'm moving left and right, that's affecting my x value of my coordinate. And if I'm moving to the right, that's in the positive direction. So I need to write x plus 8. Now let's look at our y. From P to P prime, I went down. Well, I went down 2. So let's write that. I went down 2. And I know that that's affecting my y value when I go up and down. And by going down, I'm subtracting 2. So my rule is going to be that I take my x and my y values, and when I map them, I have to add 8 to my x and subtract 2 from my y. So this is the rule that you would have for this picture here, taking P, Q, R, S and mapping it to P prime, Q prime, R prime, S prime. And then there's a U try for you to do there. Here they provided you with the first triangle, but they didn't provide you with a picture of the second one. Rather, they gave you the coordinates. So maybe it's a good idea to graph this one and use the coordinates they gave you to graph the second picture. That way you can see visually what happened and you can describe the rule.